Hi guys, and welcome to the Indices and Surds. Again, the answers are already on this page here. I'm just going to walk through the example or the try it questions as they're noted here, and then hopefully that's enough, and then you can just go through the answers. Any questions you've got, just email them on into myself or Mr. Parry. Device battery is low. Hopefully we'll get through this one. So simplify these expressions. So really the thing to remember is this is just one big long multiplication. So it's 5 times x cubed times 2 times x to the power of 7. So multiplication you can do in any order. So we'll have the 5 times the 2 out first, which makes 10. And x squared times x to the power of 7 is x to the power of 10. Okay, so that's A. For B, perhaps the nicest way to do it is to write it as a fraction. It's got 18x to the power of 9 over 3x squared, so we can see in this fraction form here, you can simplify this. 18 divided by 3 is 6, so we get left with 6 on the top, and x to the power of 9 divided by x to the power of 2, rules of indices there to subtract the index numbers, so we go down to a 7 there, so we end up with 6x to the power of 7. And then for C, 2x to the power of 6 to the power of 4, so that's 2x to the power, let's just write it out, that's 2x to the power of 6 times 2x to the power of 6 4 times, okay, so then you end up with 2 times 2 times 2 4 times, which of course is the same as 2 to the power of 4, so we can see quite quickly that actually all we need to do is raise every term or expression within this bracket to the power of 4, so we'd end up with 2 to the power of 4, which is 16, and then x to the 6 to the power of 4 is x to the 24, because you'd have 4 lots of x to the 6 times by itself, or we can think of it as just 6 times 4 there. So we get 16x to the 24. And then finally for D, we're just going to square this term. So again, just thinking about it, it's just x cubed over 3 times another x cubed over 3, which gives us x to the power of 6 over 9. And again, really all we've done here is applied the squared index number here to the two terms within the fraction. Okay. Right, so walking through our rules of numbers in index form. So half means square root. Okay, so square root of 36 essentially is what that means, which is 6. 27 to the 2 over 3, we could write that as 27 to the third squared, because we apply one of those earlier rules. That just means if we times 2 and a third together, we can make the 2 thirds again. So just rewritten it. 27 to the power of the third means the cube root this time. So we had the square root for a half, so it's cube root for the third. So cube root of 27 is 3, because 3 times 3 times 3 is 27, and then we'll square it. So then we end up with 9. Okay. 64 to the power of minus 0.5, or 0.5 is the same as a half. So we could rewrite C as 64 to the power of negative a half. And then we can write that as 1 over 64 to the half. That's just applying, but then we have a negative index number that's the same as 1 over. And then finally, that's 1 over square root of 64, which is 8. And then finally, a half to the power of 4 is the same as 1 to the power of 4 over 2 to the power of 4. Just apply that power of 4 to both those numbers there as before. So we end up with 1 over 16. Okay. So for these ones, we just want to rewrite them first. That's really all the problem is, exactly the same as the questions above. So if we had x squared and then we wanted the fifth root, which is what we've got here, we'd write that to the power like that. So that'd be the fifth root of something. The x squared is the something. And then we multiply these two numbers together in index form. We end up with x to the power of 2 over 5. Okay. Walking through the rules for this one, we would have 3 over x to the power of a half to start with. But if we want to bring it up, then this really does simplify it. Our rule is if it ended up in the denominator there, it must have been because it started life as a negative. So we've actually got 3x to the power of minus a half. Okay. For C, we just simplify. So we've got 3x squared over x to the power of a half. Rule of index number, so we subtract indices under division. So 2 take away a half is 1 half, or 3 over 2. So we end up with 3 times x to the power of 3 over 2. And then finally, just rewrite this one out, is x to the power of a half over 3x to the power of 1. So x to the power of a half minus, so the half minus the 1 if you like, and then we'll end up with x to the power of minus a half over 3. Okay, so the important thing to note here is that the it's got like a 3 here and a 3 here and a 3 here. That 3 doesn't move around. If it's in the numerator, stays in the numerator. If it's in the denominator, stays in the denominator. Really, because it's just, like for instance, if we take c, it's just 3 lots of x squared over root x, like what we could say 3 over 1 lots of it. So we can simplify this separately and then just still apply that multiplication there at the end, or in this case a division at the end. Okay, and simplifying surds. So when we simplify surds, it's a little bit like if we were to simplify an algebraic expression, we want like terms. So if we have a look here, to simplify that 28, we probably want to turn it into something root 7, because then we can subtract it. We want something root 7 minus something root 7, and then that makes sense. We're just saying how many lots of root 7 have we got. So root 28, you can separate these into their factor pairs as root 4 times root 7, and that's quite nice because root 4 is a square number that we know therefore the answer to, so that gives us 2 root 7. So it's a very large B buzzing around my fingers. It'll be fine. So now we've got 3 times 2 root 7 minus root 7. 3 times 2 is 6, got 6 lots of root 7 here, minus root 7, so in total we've got 5 lots of root 7. For here we want to rationalise the denominator in b, okay, so that means to ensure there's no irrational number, i.e. the square root of 3 is an irrational number, it's a non-terminate decimal. We don't want that in the denominator, so the only way to remove it is to find an equivalent fraction. So we've got to multiply the denominator and the numerator, but let's just set those the wrong way around, so the denominator and the numerator, multiply them both by root 3, okay? So that ends up with 4 times root 3, which is just 4 root 3. But then root 3 times root 3 takes us back to 3. If I multiply the 2 square roots of a number, which is the same, get back to the original number, so that just then gives us 4 root 3 over 3, okay? C is a little bit trickier here now, so we need to use what's called the conjugate, and it creates an expression or a multiplication you might be familiar with called difference of 2 squares. Okay, so we need to rationalise this, we need to get rid of the 1 plus root 2. So the only way to do it is to multiply 1 plus root 2 by 1 minus root 2. Okay, and then we have to do that to the top and the bottom numerator and the denominator. So let's see what that creates. So we multiply the numerator first, it's 3 times 1 minus root 2, so that'll give us 3 minus 3 root 2. And let's have a look at this result that occurs when you multiply the denominator by, again, its conjugate. So we get 1 times 1, which is 1, and we get 1 times minus root 2, which is minus root 2, my B friend is back, and we get root 2 times 1, which is plus root 2, then we get root 2 times minus root 2. So root 2 times root 2 is 2, but then we've got the minus, so it's minus 2. Okay, so we've created a situation here in the denominator by which, because we picked the positive and negative version of the same bracket, these terms here in the middle, the minus root 2 and the plus root 2, will always cancel. So we've got rid of the irrational number in the denominator, so then we end up with just 1 minus 2 is negative 1, which we could even simplify. So we divided both the 3 and the minus 3 root 2 by minus 1. They would therefore change signs themselves, so we end up with 3 root 2 minus 3. Okay, and then finally for D, I'm going to do the same business, so let's see if I can get this done in a minute. So we have root 5 over root 5 minus 2. We're going to multiply top and bottom by the conjugate. Root 5 plus 2, root 5 plus 2, so just change the sign here on this irrational denominator. So in the numerator we get root 5 times root 5, which is 5, plus root 5 times 2, which is 2 root 5. And then in the denominator we're going to get root 5 times root 5, which is 5. We're going to get minus 2 root 5, but we're also going to get plus 2 root 5, so that'll cancel, so I'm going to bother writing that down. And we get minus 2 times 2, which is negative 4, and then obviously that's 1, so you just get 5 plus 2 root 5, which I think is all of it. Yes, brilliant. Okay, cool, so we've got that done in 10 minutes, so any questions, just let us know, send an email. Hope you're doing alright with all of these, get them marked, and you'll be fully prepared for your A-level course, hopefully starting in September.